You know, I keep seeing the reoccurring theme, pressure gauges, out in the unit. Every time I go to a plant, no matter if they're top tier or bottom tier or middle tier, why are the gauges always bad? Do we understand that the gauge is actually just a little balloon hooked through a branch connection to the process? It's as close as we come to allowing the oil out of the pipe. And when a gauge is bad, block it in and put a tag on it. Don't just leave it going. Make sure that the root valve is closed down enough just to allow enough pressure to activate the gauge, but not too much in case it does blow out. I think it's something that if you get 4 or 5 gauges that are bad, maybe we need to have maintenance come out and change them. But in your surveillance rounds, when you see gauges that are not operating properly, I think it's definitely something we need to take care of and not just ignore. Gauges are great for troubleshooting. How do you know what levels may be in a tower above the process? How do you know what the discharge and suction pressure is on a pump? They're very important and they need to be maintained, and they need to be taken out of service if they're bad. You know, I just got back and I see again the same thing. I see egress and access pathways blocked up with debris, dunnage, hoses, insulation, barrels of trash. And do people that work in the unit realize that it may be them that are gonna have to egress through that pathway one day in case there's an emergency? We have a classic example of this happening during a major coker fire where the top unheading device was open, flames were shooting out 300 feet. The operators on the cutting deck could not escape. They ran out to the stairway, but it was blocked off from a bunch of maintenance debris. And they had to run back through the fire. Now, whose responsibility is this? It's our responsibility in the unit to make sure people clean up after they do their work. If it gets to be a buildup, we have to get it removed. Every time I go into these plants, I see the same thing over and over and over. So how are we going to solve this problem? Those egress pathways are made for you. You, the operator. You, the maintenance person. You, the contractor. You, the engineer that may be troubleshooting something. If there's an emergency, we have to be able to egress. Hi.
practice in the refining industry. Boiler feed water is expensive, so returning the condensate can save you money.
You know, Paul, one of the things I can't understand is how we've had major accidents happen and we haven't learned from our mistakes. So this is Gary from Refining Community, and I wanted to bring everybody's awareness to fire extinguishers. Fire extinguishers are hung, if you'll notice, on a special rack up off the ground, off the grade, away from pockets of water. They're usually inspected by a lot of plants. It's third party, the guards or the safety department. So one of the things that I've been seeing is that some fire extinguishers are left to sit in either dirt, water, on the grade. And the reason this is so important, we had a major fatality, every fatality is major, at a plant where they charged the fire extinguisher. The bottom had corroded from sitting on the concrete in a wet environment. And when the charge of the CO2 hit, it blew the bottom out and blew it up and broke their neck. So that's a lesson learned that we don't want repeated. So anytime if you see a fire extinguisher sitting on the ground, even temporarily, let's say somebody's doing a weld job and they have a temporary fire extinguisher, it's okay for one day or one shift, but it should be taken away, it should be put away, and the ones that should be in the bracket with the covering on it, that's how they should be. So I think we need to come back to our basics when it comes to fire extinguishers. Lessons learned. In the classroom, I have a section in my reliability materials about the lubrication of the hoist. Some places call it the winch. And it was startling to me when I was discussing the lubrication of the winch. And one of the students asked, in this picture, you show, where's this lubricator? Where's this place where you put the oil? And you said it gets 6 to 9 drips a minute, that you oil the air. And I said, it's underneath the control panel. There's 2 wing nuts that you remove and you lift the control panel front off, and there's the lubricator and the sediment bowl. And he said, really? Come to find out, they never knew that it was there. And they'd had a lot of winch failures, not knowing that it had to be lubricated. So that was a lesson learned for him, a lesson learned for me, and it was one of those stories I loved to tell. Lessons learned. In the training class, where we can sometimes have 10 to 15 different refiners, I was discussing and pointing out the mechanisms that cause drill stem failure. And I'm going through my material and I'm pointing out that a lot of the drill stem failures are from cutting techniques. As we de-inventory the coke drum, taking out hundreds of tons of coke, if the coke cutter, sluicer, driller does not do it properly, it can pinch the drill stem and cutting tool. And cutting from the top down, obviously, I mentioned, is one of the methods that we have to do and not take too big of ledges. And the gentleman in the back says, Gary, you mind if I ask the rest of the class, does everybody in here cut from the top down or from the bottom up? And unanimously, the class said from the top down. So he sits back down, I finish my material, and later at break he came up to me and he says, Gary, for 40 years we've been cutting from the bottom up. We have a lot of damage to our drill stem and our cutting tool. We have a lot of plug offs, and we've always wondered why. So because he was alone without any outside information, he didn't even know that you could cut from the top down. So that was a great lesson learned for him, for me, and for the industry. Gary from the field. The subject I'd like to talk to you today about is serious because it could be very harmful for everybody involved. And that's good lockout tag out on a pump. And the incident that we'll talk about later was caused by not locking out everything we opened, everything we closed, everything that we touched basically should have a tag on it to show the operators the next shift or the next day after the pump is repaired what we had opened and closed. So the incident happened on what we called a stabilizer charge pump. This is sour naphtha. I think the suction pressure, if I can remember 30 years ago, was about 250 pounds suction pressure, and the pump boosted it up to 480 pounds. And the operator went outside, we put the pump in service, and he goes through the checklist and removes all the tags, closed all the valves, opened all the ones that were necessary, cracked open the suction. And when he cracked open the suction valve, somebody had started to replace the pressure gauge on top of the pump, and it was still hanging in a little bracket, but all they did is remove it enough that it wasn't tight anymore, and he got covered in sour naphtha. So there was a classic example of finish your work and tag out anything you open or close. Hi, I'm Gary Pittman. I give the fundamentals class for delayed coking. I talk about operations and reliability. And what I've found after being at over 100 cokers worldwide is that there's a certain group of people that need to build up a foundation of knowledge about the unit they're in. They're either new process engineers, new supervisors. Every operator can benefit from my class. We've given it over 2,000 people, either in the refinery or at the training that we hosted before the seminar. And one of the things that I think most people get is that we start right from the basics. Why delayed coking? Talk a little bit about the financials, why delayed coking makes money, and then we go into the major pieces of equipment. Spend a lot of time on our more troublesome equipment, such as the SP valves on the switch deck, the decoking equipment, in some cases the unheading equipment, but that reliability's gone through the roof as far as being a wonderful piece of equipment. And the other thing that I like about my class is I'm an ex-operator, always an operator by heart, and I bring it to life that we have ownership of the unit. We spend a little time talking about PSM and safety, talk about the incidents that's happened in our industry, and I have a whole section that's just on the reliability of the structure, major equipment. So if you take that book, and it's over 300 pages, and you get to the section on reliability, there's 50 pages of just gold. You can just take it back to your plant and say, are we doing this? And I guarantee you that you'll have better reliability. So come and join us. This will be before the RefCom seminar, and if you want it hosted at your refinery, we've done that numerous times. So I hope to see you there.
Hi, my name is Evan Hyde, and I am the instructor of the Delayed Coking Troubleshooting Process and Design course at coking.com and the RefCom seminars.
A little bit of introduction about the course. As the name implies, we talk about coking specific equipment. So I'll give you an example. So we talk about the reliability and design of the jet pump, not pumps in general. We talk about decoking equipment, we talk about steam purge valves, we talk about furnaces, all the specific design features that we have in the delayed coker. And then we get into reliability and troubleshooting. So common reliability issues with furnaces, fouling, steam purge valves, reliability, looking at failure modes and mechanisms for decoking equipment, things you can do to improve this equipment. So it's really all about hands-on, real-world experience with regard to coking specific equipment. And the people that tend to enjoy participation in our class are engineers associated with the unit, so that's process reliability engineers. Inspectors often like to come because we spend a lot of time talking about fixed equipment reliability and drum cracking, for instance. And we also get folks in the operations team, so for instance the operations unit supervision, and quite often we get unit operators as well that have a lot of experience, and they stand to gain by learning some of the more technical specifics of the unit. And we really enjoy their participation because they have a lot of hands-on experience that the 1 or 2 year process engineer doesn't necessarily have. So it's really all-encompassing group, but we do have the minimum expectation that folks will have some coker experience because we do dive right in. 2 days goes by really fast, and we try to really get into the weeds about this coker specific equipment and try to give you some examples about how to make your unit better. So we hope you can attend. Thanks.